Yeah, good evening, everyone.
Good evening.
You just wait for 1 more minute, then we can start. Wait for 1 minute. Okay, so now we continue. The time is over. Let's start. So we had started with electricity. Okay. And we were doing the electric circuits. Today we will try to understand the electric circuits. And after that, we will do Ohm's law. We will apply Ohm's law to complex circuits also. So see, first we start with the Ohm's law. See, every year in board exams, you have questions pertaining to the Ohm's law. Ohm's law is somewhat a question which will be applicable everywhere. It starts here in your class 10th and it will move on further in whatever class you go. You find your Ohm's law. Okay. So, what does Ohm's law state? It is specified. It was. It specifies a relationship between electric potential and current. This Ohm's law, it was given by George Simon Ohm. Okay. So according to the Ohm's law, Ohm's law, it states that the potential difference
Good evening, sir.
yeah, good evening. Potential difference between any 2 points of a conductor is directly proportional to the current. So the potential difference is directly proportional to the current provided physical conditions physical conditions like temperature and the dimensions of wire remain constant. Okay. So if you have the potential difference and current, so current is directly proportional to the potential difference, or you can say that the potential difference is directly proportional to current. Both are actually the same thing, current and potential difference. So for this, we consider here an electric circuit. So let's draw an electric circuit which is represented with battery, a cell, a switch, and after switch you have an ammeter, then the voltmeter, then your device. So you have the device, let it be bulb, or instead of making it a bulb, I can make it to be a resistance. Yesterday I told you that we can represent the devices with this symbol, which we call as the resistance. So from here you obtain your value. So this is your resistance R, and suppose I measure the potential difference B across this. So as we discussed that current is the rate of flow of charges and it is measured by the ammeter. So current will be measured in ampere. It is a rate of flow of charges. So it's written as current I is written as Q by T, the number of charges crossing a given cross section per unit time, that we call as current. And electric potential V, it is measured in volts. So since charges are conserved, so whatever current will be shown over here in the ammeter, the same current comes over here at the junction where we have connected the voltmeter. Let these points be A and B. So suppose we have these 2 points A and B. You have the point A and another point B. The voltmeter is measuring the potential difference between the points A and B. Or you can say that the voltmeter is measuring the potential difference across the resistor. Okay. Since there is no other device connected, so there is no other potential drop that is occurring. The only potential drop that occurs is across this resistance between A and B. Okay. So here we have the resistance R between A and B, the current between the points A and B. So let that current be I. So we have here some current I flowing. So whatever current comes over here at this point A, from point A, there are two paths for the current to flow. How many paths are there at point A?
Two. Two.
Yes. How many different paths are there for the current to flow?
Two.
Two. Okay, so from point A, either the current can pass through this bottom part, like from here, or it can pass from here. So the voltmeter has a large resistance. It has an infinite resistance, because of which very small, you can say negligible amount of current comes through this voltmeter, and almost all of the current passes through the resistance only. As we want our work to be done across the resistance, we don't want our current to be wasted out. Okay, so if it is being passing through the voltmeter, it is just a waste. We are not getting any work done from it. We are just able to measure the potential difference. That's it. Okay, so this voltmeter requires a very small amount of current. So you can suppose that whatever current I is moving from here, the same current I passes through this resistance also. Okay, so either you connect your ammeter here or you connect your ammeter here, anywhere, so it will show the same current reading. Got it? So another point we noted here, that our ammeter has zero resistance. An ideal ammeter has zero resistance, whereas a real ammeter will have a small amount of resistance. Okay. Zero resistance means when you have connected this ammeter in the series circuit, so it is not using any power of the circuit. It doesn't use the power of the circuit. The power of the circuit that is being used is very small. So it uses a very small amount of the power of the circuit. Got it? So ammeter has a very small resistance, which we say zero resistance, whereas a voltmeter, it has infinite resistance. So a voltmeter is connected in parallel, whereas an ammeter is connected in series. Now again coming to the Ohm's law, what does the Ohm's law is stating? The Ohm's law is stating that the potential difference V will be directly proportional to the current. Okay, or you can say that the current flowing through this wire AB will be directly proportional to the potential difference. So I can write it like this also. I can write V to be proportional to I. This is what the Ohm's law means. So as a statement of the Ohm's law, we can write it here that according to the Ohm's law, we have V directly proportional to I. Okay, or I directly proportional to V. Directly proportional means if you draw a graph between V and I, so it will be a straight line and the slope of that graph will be equal to the division of this. So if you divide V by I, you will get always a constant number. This constant is called as resistance. Okay. So what is resistance? It is the ratio of electric potential to the current, and it is always constant. Had it been a variable, so Ohm's law is not held over there. So Ohm's law is valued when potential is directly proportional to current. We can write V proportional to I. So we say Ohm's law is valid over there. The ratio V upon I is called as resistance. The geometrical or graphical meaning for this is that if you plot a graph between V and I, you get a straight line like this. So this means if you draw, and also it always start from this zero. It will always start from this zero. So the graph between potential and current. Suppose here I plot potential. On the x-axis I plot current potential. Here I plot current. So the potential is directly proportional to current means we obtain a straight line between V and I. Got it? So we have V directly proportional to I. Understood everyone? The ratio V by I is equals to R, which is constant. Okay, so this is constant, which we call as the resistance. Got it? Yeah, understood?
Yes, sir.
Okay. So see, the slope of the graph will be what I obtain as V by I. That means I can say that the slope of the graph will represent the resistance of this appliance. Okay, let us see some questions based on it. We'll see some questions based on Ohm's law. See, we are doing this topic 2 times, 3 times so that you should be able to get with this topic well. Okay. Just give me 1 minute. I'm just opening up some PDF relating this so that you can have questions based on it. Okay, so I just got one question. Let's do that question. See. Okay, for this one, just have a look at this question. If you can solve it, very good. Otherwise, I'll solve this out. Draw a VI graph and use this graph to find the potential difference V when the current I is 0.5 ampere. So you have to plot a graph between potential difference and current. The smallest value of the potential difference is 0.5 and the maximum value is 2.5. So what scale should we choose? Yes, what scale should we choose? Yeah, anyone?
Sir,
Can you
can you
try to
repeat?
plot this? Yeah, can you try to plot this? Dharya?
Sir, sir,
Okay, try
sir,
to plot this. Yeah, what?
y-axis,
Hmm?
y-axis is the current in amperes.
Okay, we take y-axis as current in
Sir,
ampere.
V will be the y-axis. Potential difference will be y-axis,
You
and
can
the
take either,
current.
or you can take either one on the x-axis and either one on the y-axis. Yes, anyone got this? Let's try to plot it now. I'm plotting it out. I waited. I thought that you must have plot. Ayonija, have you plotted? Ayonija,
No, sir.
are you trying? Aryan, Arav, Sudhamshu, are you trying to plot the graph?
Yes.
Siddharth, what happened? Are you trying to plot?
Yes, sir.
Yes. So try to plot it. I'm expecting the results. I'm also putting my effort. I'm also trying to draw it over here. So by choosing appropriate axis, I'm trying to plot it. Uh, so see here, if I plot, I'll be getting, need to mark the points over here as, okay, I need to choose my scale on my own. Okay, just one. Okay, so I'm just putting the values over here and we will obtain the graph. Okay. So see, I'm just Just to be quick, I'm using this method, whereas you have to take your points and then draw. So see, I obtain the points which I have chosen. Okay. So for potential 0.5, 1.0, 1.5, 2.0 and 2.5. Okay, so let's say we take potential on the x-axis. It's okay. So we take x as 0.5, 1.0, 1.5, yeah, 2 and 2.5. And for y the values are 0.2, okay, so y is 0.2 and then 0.4, 0.6, 0.8. Okay, so y is 0.2, 0.6, so it's 0.4, then you have 0.6, then you have 0.8, then you get 1. Is it? Yes? Are the points the same? Yeah, 0.2, 0.4, 0.6, 0.8 and 1.0, they are the points which I have plotted over here. So you can see the points are visible. I can see the points now. And now using those points, I can draw the graph. So let's try to draw the graph. So these are the points, see. And if I join them with a straight line, I get a graph. Okay. So is it a straight line? Yes. Do I obtain a straight line by joining these 2 points? If I join all these points, so do I get a straight line?
Yes, sir.
Yes. So I get a straight line by joining all these points and then see the questions that are asked here. So the scale, this is a graphing calculator. I can use this graphing calculator to obtain the results. Okay. However, it can also plot the line also, but I didn't requested it to plot the line. I just plotted the points and I got the graph. Okay. Now see what all questions are asked. My first question is draw VI graph. So we have done. A is the potential difference V when the current is 0.5 ampere. Okay. So see from the graph, when the current is 0.5, what is the potential difference? Can anyone read and tell the potential difference? If you want to zoom a little bit, I can, but I think at this stage it is identifiable.
0.2.
Yeah, it is 0.2. Got it? So it is 0.2. A simple way in this graph, it works like this. If I carry my cursor at this point, so it will show the coordinates 0.5, 0.2. So it's 0.2. Got it? Current here is 0.2. I can write here current I. So when current is 0.5, the potential V is, oh sorry, current you have to take as 0.5 and then tell the potential. So potential is on the x-axis. And this is the point, I think. Now this is the point which represents your current. Current to be 0.5 ampere. So what is the potential difference at this point? Can anyone guess the potential difference? See, on the x-axis we have plotted, on the x-axis we have taken potential, on the y-axis we have taken time. On the y-axis we have plotted the current. Okay. So when the current is 0.5, the potential turns out to be here as 1.25. Okay. So 1.25 is not visible from the graph, so either you write it as 1.2 or 1.3. Then the second question. Yes, are you getting this or not? The same graph can be plotted like this also.
Yes, sir.
I can plot that graph over here also just by taking a grid, and on the grid I can choose my axis here. So here I choose my axis. Let this be current and let this be your potential difference. So this is our potential difference V. Here we obtain current and we take our points to be, let this be 0 0.2, 0 0.4, 0.6, 0.8 or 1.0, or just make it a little bit bigger. So we make two points, 0 0.2, 0 0.4, 0 0.6, 0 0.8, and then you have 1.0. Here you get on the current. The potential was to be taken as 0 0.5. Is 0 0.5, 1, 1.5, and here you get 2, finally you get 2.5. Here you get 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1.2. So the points we have chosen 0 0.5, 0 0.2, potential 0 0.5, 0 0.2. So this is the point. The second point we obtain 0 0.4, 1. Okay, potential 1, and this one is 0 0.4. So this is the second line. The third one 1.5, 0 0.6, 2, 0 0.8, and hence by joining this we obtain a straight line. So you have to tell the current when the potential difference, when the current is 0 0.5. So here the current is 0 0.5 at this point. From here current is 0 0.5 ampere. So it is touching the graph at this point. And here the middle portion of this 1 and 0 0.5, 1.5. So we get potential difference V will be equal to, V is equal to 1.25, which will be exactly half in between them. So this is electric potential. Then we can obtain the current I when the potential difference V is 0.75 volts. Okay, obtain this. Take the current to be take the potential to be 0.75 volt, and then at that point what will be the current. So its potential has to be 0.75. That means between 0.5 and 1, that is 0.75. So this is your 0.75. From here I drop a perpendicular, it cuts over here, and it is equal to a current of 0.3 ampere. So answer for this is 0.3. Are you people getting?
Yes, sir.
Yes,
Yes.
sir.
Don't keep on sleeping. Just next, I will be asking you to plot these graphs. Okay. Find out the resistance of the circuit. Find the resistance of circuit here. Yes. What's the answer? What is the resistance? I'm expecting the resistance from anyone. Is there anyone who got the resistance? Don't just sit and be a dumb. Answer. What's the resistance here? The resistance will be obtained as V over I. Hmm? I know, similar. Or- Yeah, Siddharth, what's the answer? Siddharth,
Sir, R is equal to 4.16.
4 upon. You can take either value of the potential and either value of the current. Okay. So you can use like, if you use 0.5 as potential, so your current is 0.5. Use it. So we get R equals to V over I. V is 0.5. The current is 0.2. So you get 5 by 2. 5 by 2 is 2.5 ohm. That's the answer. Okay. Let's see some more questions. Okay, draw an electric diagram of a circuit consisting of a cell of 1.5 volt, 10 ohm resistor, 15 ohm resistor, and a plug key, all connected in series. Okay, so can you do this question? Just you need to draw it. Just draw the circuit for this diagram. Draw a circuit diagram for this. So definitely the circuit diagram would include what all things will be present in the circuit diagram? Yeah, see, I am just observing that all of you are becoming inactive. You're not responding. Aryan? Aryan?
Yes, sir.
Yeah, what can you draw the diagram for this one? Have you drawn the diagram?
Doing, sir. 1 minute.
Okay. I will see everyone's answer now. So just note down the question. I want to see everyone's answer. Okay, so let me show your answers, everyone. Now I want to check everyone's answer. Just show.
Once can you show the question?
No, I won't show the question. I want to see the answers. Okay, the questions were there for 2 now. Abhinav? Yeah, Abhinav? Darya? Darya? Siddhisri? Sudhanshu? Have you drawn the diagram?
Sir, only the ohm resistance symbol I forgot, sir.
Okay, just show your answers. Everyone just keep a turn on your camera and show the answer. Sumuk? Yeah, Sumuk?
Sir, can you see mine?
Okay, so this one, find a battery of 1.5 volt. Okay, fine. Okay, so Sumuk, why you haven't done? The question was they are visible for around 2 minutes. Okay. So this should not happen from the next class. For all of you, I say that this should not happen in next class. Bye all of you. See you again in next class.
Sir, completed.
Okay, just show. Okay, good. Okay, bye all of you. Nija, have you done?
Yes, sir, I have done.
Okay, show it. Just 1 minute, Nija. Okay, see, battery that you have drawn, it has been drawn incorrectly. While drawing the battery, you have to check the one of the terminals should be positive, then negative, then positive, then negative. Okay.
Okay, sir.
Okay, bye. Bye all of you.